Hi, welcome back to Elementary Algebra. I'm your instructor, Amy Fuchsteiner. We are going to be looking at rational expressions today. Rational expressions are expressions that involve the use of a fraction. So while these will not be numerical fractions, they are going to be fractions with variables in them. So in 7.3, last time we met, we looked at rational expressions, their addition and subtraction when the denominators were the same. Today we're going to be going through what happens when those denominators are different. So there are four basic stages to this. The first is that we're going to have to find the lowest common denominator. To do that, we will need to make sure that we have factored all of our denominators completely. Then we're going to look at building up those terms so that they all share the same common denominator. We'll add and subtract as needed using that common denominator, and then we're going to look at simplifying the result. This in of itself can include several steps, including any distribution or combination of like terms. And for our final step, we will double check to make sure that whatever our new numerator is, that it has been factored completely and doesn't cancel. Isn't left to cancel with anything in our denominators. So let's go through a few of these problems and see how it goes. All right, so our very first problem is a over 11 plus 2a over 3. This has two terms in it, to the a over 11, which we're going to add to the 2a over 3. The two denominators that we have are the 11 and the 3. 11 is already a prime number. It cannot be factored other than 11 times 1. 3 is also a prime number. It cannot be factored other than 3 times 1. So when we look for our lowest common denominator, what we do is take everything in our first denominator, that's the 11, and we multiply it by those factors of the second denominator that were not included already. 3 is a new factor. It was not included in the 11. So our lowest common denominator will be the product of those two, 11 times 3. So with my new denominator, which is 11 times 3, I'm going to take my first numerator, that's the a, and what would I need to multiply the a by in order to build it to a denominator of 11 times 3? Since the a was already over the 11, it already had a denominator of 11, and I multiplied that 11 by 3, I'm going to need to multiply that a by 3. Now, I'm going to add, just like it says here. I'm going to take my second numerator, which is 2a. That was originally over a 3. Now, I built a new denominator of 11 times 3. And since I had to multiply the 3 by 11, I will also need to multiply the 2a by 11. To simplify the numerator, I simply multiply the 3 by a and add that to 2a times 11, or 22a. Now, I can do 11 times 3 if I want, or I can leave it 11 times 3 for the time being. I'm going to do 11 times 3 is 33. To further simplify, I can add the 3a to the 22a to get 25a over 33. Now, I have added or subtracted the rational expressions using the common denominator. Now I need to look at whether or not I can simplify this result. A will not cancel with anything in the denominator, and 25 does not cancel with 33. So this is it. This is as much as I can do. And that is my final answer for the addition of those two terms. If we look at problem number 2. Problem number 2, we have two terms. We've got 3 over 28z minus 5 over 21z. So I want to look at all the factors for 28z. 28 is 2 times 2 times 7 times z. 21 would be 3 times 7 times z. So to find the lowest common denominator, we use all of the factors in the first denominator, 2 times 2 times 7 times z, and we multiply by any factors in the second that were not already listed in the first. Since the 7 and the z were already in the first, they're already included, I only need to add the 3. This is now my lowest common denominator. I myself prefer to leave all of the factors listed. It just helps me to have that visual so that when I look at my first numerator of 3, and I see that I've already used the 2, the 2, the 7, and the z, the 2, the 2, the 7, and the z, I now know that to match the multiplied by 3, I'm going to need to multiply by 3 here. Similarly, when I use the 5, I did the 3, the 7, and the z. So in order to build this denominator to match this one, I had to multiply by 2, 2. So I've got to multiply this by 2, 2. 2 times 2, sorry. So this gives me a 9 minus 20 over, and now that I've got that piece, I might want to simplify this denominator to 84z, which is a negative 11 over 84z. Now I want to check to be sure that nothing further cancels. 11 does not go evenly into 84. I know it doesn't because 84 I got from 2, 2, 3, and 7. I didn't use an 11 at all there. So a negative 11 over 84z. When we're looking at problem number 3, we actually have denominators with variables in them. So for 2x, recognize this as the factors 2 times x, and x squared as the factors x times x. Then the lowest common denominator would be everything in the first, 2 times x, and I need to multiply that by any additional factors in the second denominator. Well, the first denominator only had 1x. This has an additional x, so I need to multiply this by another x. This gives me a lowest common denominator of 2 times x times x. Is that 2x squared? Yes, but I do like to make sure that I'm including everything. So I am going to write it as 2 times x times x. I'm going to take my initial numerator, which is x minus 3. Notice I'm using parentheses because that numerator goes all together. It was over 2x. Out of my current common denominator, I am missing an x. So I'm going to multiply by x. My second numerator is x plus 3. That was over x times x, which is missing the 2. So I'm going to multiply this by 2. Cleaning it up a little bit, this would be x squared minus 3x plus 2 times x is 2x. 2 times 3 is 6 over 2x squared. Combining my like terms, I get an x squared minus x plus 6 over 2x squared. Okay, so now that this is simplified, I want to look at this x squared minus x plus 6, and I need to determine if that can be factored. Are there any numbers that multiply to give you 6, but when added, they give you a negative 1? So I want a positive 6, but when I add them together, I get a negative 1. 6 is 1 and 6, or 2 and 3. Well, 2 and 3 does have a difference. So I would think maybe a positive 2 and a negative 3. But the problem is, when I add 2 and 3, I do get a negative 1, positive 2, negative 3. But when I multiply these two together, I don't get a positive 6. This is supposed to be a positive 6. I would get a negative 6. Since this would not work, this is not factorable. And I can't do anything more to break that down, meaning it wouldn't cancel with anything over the 2x squared. So this is it. That's all I can do. Right? Okay, let's look at the next one. And the next one, I have 2x over x plus 5 minus 3 over x. My first denominator is the x minus 5. It is the only denominator or factor there. The second denominator is x. That is also the only denominator. So my least common denominator is made up of the first denominator, x plus 5. And then I want to multiply that by any factor that was not already included. That would be this x. Right? So, excuse me. We're going to do x plus 5 over x. My first numerator is 2x. I want to build it to look like x plus 5. I'm sorry, x minus 5. No, it's plus. Okay, so I thought that should be a plus. There we go. X plus 5x. It was already over the x plus 5, so to build it, I will need to multiply this by x. Minus 3. The 3 was already over x, so to build it to an equivalent term, I will need to multiply this 3 by x plus 5. This is going to give me a 2x squared minus 3x minus 15 over, I'm going to write it as x plus 5. Okay, now this is a trinomial, just like the ones we've been dealing with before. So I need to look at, is this factorable? So 2 times a negative 15 is a negative 30, which would be a negative 30 and a 1, a negative 15 and a 2, a negative 10 and a 3, a negative 6 and a 5. Or the negatives could all be the other way around. But none of these are going to have a difference of negative 3. Yeah, none of them. So that means that no, this would not be factorable. And this is as much as I can do. Okay, nice. They're not all this good. They're not all this good. The factoring is going to get a little bit more, get a little bit harder. All right, let's try a few more. With number 5, we have denominators. We have 2 terms again. We have b over b minus 3 plus 8 over b squared minus 9. Our first denominator is just the b minus 3. This is not factorable, as your b is to the first degree, so that won't break down any further. The b squared minus 9. Well, 9 is 3 squared. So I recognize this as the difference of 2 squareds. This will be a b minus 3, b plus 3. That means my lowest common denominator is everything in the first denominator, that's the b minus 3, multiplied by anything we missed. The second denominator already has the b minus 3, so I need to multiply by the b plus 3. b minus 3, b plus 3 is my common denominator. My first numerator is the b. It is missing the b plus 3. My second numerator is the 8, and it was already over the denominator needed, so I don't need to multiply by anything more. Simplifying my numerator, I have b squared plus a 3b plus 8 over b minus 3, b plus 3. I need to determine, does the b squared plus 3b plus 8 factor? Is that factorable? What 2 numbers multiply to give me 8, but add to give me 3? Nope. It's not factorable. And because it is not factorable, that means there will be nothing available to cancel. And that's it. That's all I can do. That is my simplified answer. Similarly, if I'm doing number 6, looking at the first denominator, I have k squared minus 12k plus 36. I want to see if this factors. Are there 2 numbers that multiply to give me 36, but when added, I get a 12? Oh, hey. Yeah, actually a 6 and a 6, right? So this will factor into a k and a k. I need a 6 and a 6. But if they're both positive 6, that would give me a positive 12. So I need these to be negative. With the second denominator, is this going to factor? Well, both of those are even. So I can pull a 2 out. And I'm left with k minus 6. So my lowest common denominator will be everything in the first. That's k minus 6 times another k minus 6. And then I want to multiply by anything I'm missing in the second. I've got a k minus 6 already, but I haven't included the 2. So I need to put the 2 in here. All right. That makes my lowest common denominator 2 times k minus 6 times k minus 6. So with my first numerator being a k, it was over k minus 6, k minus 6. The only piece I'm missing is the 2. So to build this fraction up so it fits over that denominator, I will need to multiply the k by 2. The subtraction sign stays, as does the 3. The 3 was over 2k and 2 and a k minus 6. I've got a 2 and a k minus 6. So if I want to build this so it fits this denominator, I will need to multiply by k minus 6. Simplifying the numerator, I have a 2k minus 3k plus 18 over 2 k minus 6 k minus 6. 2k minus 3k is a negative k plus 18 over 2 k minus 6 squared, because it's the same factor twice, so I can write that as k minus 6 squared. The k plus 18 is not going to cancel with the k minus 6. They have to be exactly alike to cancel. So this is it. This is as far as I can go. Number 7 represents what happens when you don't have fractions in both of them. Here I have a 10y over y minus 5 minus a 3y. So we're going to do what you do. Basically, it's a little bit of a sneaky trick. If you just make that a 3y over 1. And when you make that a 3y over 1, you now have two denominators. Your LCD, your lowest common denominator, is all of the factors in the first denominator multiplied by anything in the second that wasn't, so just 1. So my lowest common denominator here is just a y minus 5. That 10y will stay the same because it was already over a y minus 5. I'll subtract the 3y. But to build this so it fits over a y minus 5, I will need to multiply it again by a y minus 5. This gives me 10y minus 3y squared plus 15y over y minus 5. Or a negative 3y squared plus 25y, combining my like terms, over y minus 5. Can I factor anything out of the numerator? I can. It's leading with a negative, so I'm going to pull a negative out. And then I can also pull out a y. And that's going to leave me with 3y plus 25 over y minus 5. Can I cancel anything? Well, the y minus 5 is a binomial. It will only cancel with another y minus 5. Since that's just a y, I can't cancel these. I'd have to have a y minus 5 to make it cancel. The 3y plus 25 doesn't have a match. So that's as far as we can go on this. All right. We'll do the same thing for problem number 8, only it's just on the front end. So I'm going to rewrite this as b over 1 minus 3 over b minus 2. So now when I do my least common denominator, it's everything in the first denominator, 1, times anything in the second that wasn't already counted. So that's b minus 2. So my denominator is going to be b minus 2. So I'm going to start with that first b, and I need to multiply this by b minus 2. So I'm going to multiply by b minus 2 minus the 3, which was already over b minus 2. So that's good. So this is going to be b squared minus 2b minus 3 over b minus 2. All right. Now I do have a quadratic. It is a trinomial. Is this factorable? Because if it's factorable, then maybe it cancels with the b minus 2. Maybe not. So multiples of pairs of for negative 3 that add to be a negative 2. Oh yeah, negative 3 and a positive 1. So mental factoring, this tells me it will be a b minus 3 and a b plus 1 all over the b minus 2. Are any of the factors exactly the same? Nope. So I can't cancel anything. This is as far as I can go. That's all she wrote. Okay. All right. Great. Nothing canceling. We're simplifying, but nothing's canceling. That's okay. What's that doing? All right, so let's start with number 9. Same strategies. We want to look at the two denominators, and we want to identify whether or not they're factorable. This is a trinomial, so I want to look at the 10, and I want to determine if there are two numbers that multiply to give me a negative 10, but add to give me a positive 3. There are. For a negative 10, that would break into a negative 10 and 1, a negative 5 and 2. The difference here is 3, but I do need the signs. I need it to be a positive 3. So this would be an x plus 5, x minus 2. Similarly, for a positive 6, are there two numbers that multiply to give you a positive 6, but when added give you a negative 5? 1 and 6 have a difference of 5. But I can't have different signs because that 6 is positive. So that won't work. 2 and 3 do add to be 5. And their signs would have to be the same because this is a positive 6, right? So my signs either have to be negative, negative, or positive, positive. And a negative, negative there works. So x minus 2, x minus 3. This means that my lowest common denominator is the x plus 5, x minus 2. And that's your first denominator. The second denominator already uses the x minus 2, but I need to multiply that by the remaining, which is x minus 3. Okay. So my common denominator is x plus 5, x minus 2, x minus 3. My first numerator is the 2. It was already over the x plus 5, x minus 2. So I've used 2, but I need to multiply by the x minus 3 to build it. My second denominator is a 1. It was already over x minus 2, x minus 3. I had to multiply by an x plus 5. That's missing from that 1. So I'm going to multiply by x plus 5. Simplifying this numerator, I have 2x minus 6 plus x plus 5 all over the x plus 5, x minus 2, x minus 3. That's a 3x minus 1 over x plus 5, x minus 2, x minus 3. Now, 3x minus 1 is already a binomial. It will not factor any further. There is no common factor there. And it also will not cancel with any of those 3 factors in the denominator. So I'm just going to leave it. I can't do anything more. Could I multiply this out, the x plus 5, x minus 2, x minus 3? Yeah, but that's a lot of work that I don't want to do. And I actually like seeing the factors because I can easily recognize that 3x plus 1 is not the same as any of those factors. Sometimes when you've multiplied it all out, you can't tell in the polynomial whether or not it would factor out. So this works out well for me. All right, let's look at problem number 10. Again, we have two denominators. Is the first denominator factorable? Well, I've got a 4 and a 5. So what two numbers multiply to give you 4 but add to give you a 5? That would be a w plus 4, w plus 1. The second one is a 2w squared plus 5w minus 12. You may remember that when there is a leading coefficient, it's a little bit more of a guess and check. I tend to do these much like these guys. It's the first times the third, so 2 times a negative 12, a times c, for some of you, is a negative 24. And I want the factors of a negative 24 that will add to give me a positive 5. That's going to be a negative 3 and a positive 8. So I'm going to break this into two terms with the coefficients of negative 3 and 8. So 2w squared minus 3w plus 8w minus 12. And from the first two, I'm going to pull out a w, leaving me 2w minus 3. And from the second pair, I'm going to pull out a 4, leaving me 2w minus 3. In both of these now, I have the exact same 2w minus 3. So I'll pull that out front, leaving me a w in the first and a plus 4 in the second. So this factors into 2w minus 3, w plus 4. This means that my common denominator, which would be everything in the first, w plus 4 times w plus 1, is then combined with what's left in the second. Well, the w plus 4 is already included, so I don't need to include that again. And then I have 2w minus 3. All right. So my first numerator is 1. That's the one that was there. It's over w plus 4, w plus 1. Both were already included. I multiplied that by 2w minus 3, so I need to do the same thing here, 2w minus 3. That builds that fraction up. My second numerator is 4. That is 2w minus 3 over w plus 4. So the one that I had to multiply the denominator by, I also need to multiply that numerator by. So 4 times w plus 1. Simplifying, I have 2w minus 3 plus 4w plus 4 all over the w plus 4, w plus 1, 2w minus 3, which when I simplify gives me 6w plus 1 over w plus 4, w plus 1, 2w plus 3. Okay. 6w plus 1 is not going to cancel with any of those. I don't even have a 6w down here at all. So this is it. This is as far as I can go. All right. I should be really careful with my lines. So we want to make sure we've really separated that numerator and denominator there. Okay. All right. The last part of this goal is to add and subtract rational expressions that use opposite denominators. You may recall opposite denominators as denominators like x minus 4 versus 4 minus x. These are factors that are completely switched around. They're opposite because 4 minus x is negative 1 times x minus 4. It is the opposite because it is basically the negative of it. If we look at problem number 11, we have q minus 5, and then we have 5 minus q. Do you recognize these as opposites? The first denominator is q minus 5. The second denominator is negative 1 times the q minus 5. This would make my lowest common denominator everything in the first, q minus 5, multiplied by any missing factor. So any factor that was not previously included, so negative 1. Now, when we do a common denominator here, we can do a negative q minus 5 or a negative 1 q minus 5. It won't matter. The 9 was already over q minus 5. It's only missing the negative 1. The 3 was already over exactly that, negative 1 q minus 5. So this will be a negative 9 minus 3 over a negative q minus 5. That simplifies to a negative 12 over a negative q minus 5. Now, some people will say, hey, Amy, you have a negative over a negative. Indeed, I do. I can simplify this. That's 12 over q minus 5. I can't cancel anything further, and so we're done. Now, let's kick it up just a little bit. In number 12, with a numerator of 2, I have a squared minus b squared. Do you recognize this as the difference of two squares? A squared minus b squared is the factors a minus b times a plus b. Square root of a squared is a, square root of b squared is b. Difference of squares, square roots with different signs, right? Now, the b squared minus a squared is the negative of a squared minus b squared. It is the opposite of a squared minus b squared, or a negative a minus b, a plus b. This makes my lowest common denominator everything in the first denominator, a minus b, a plus b, multiplied by any product or any factor in the second that wasn't already included. I've already included the a minus b. I've already included the a plus b. So now I just need the negative on there. Negative or negative 1, however you prefer to write it. So this would be a 2. First numerator is a 2. It was already over the a minus b, a plus b. The only thing missing is the negative. So I'm going to multiply that by a negative or a negative 1 plus 4. It's over everything already, so that's fine. This would be a negative 2 plus 4 over a negative a minus b, a plus b. That's 2 over a negative a minus b, a plus b. Now that I have all of the factors listed in the denominator and the numerator is simplified to the best of my ability, I'm going to take a look at this negative. This is not wrong as an answer. This is perfectly fine. However, in my experience, I hate having negatives on the bottom. The negative does not have to be there on the bottom. It could be way out in front, or it could be up on top with the 2. The negative only needs to be in one spot. It doesn't need to be in all of them, but I prefer to put that negative up top. It's not wrong the other way. It's just a preference. And because I know I have a tendency to lose or forget negatives, I put them up top. All right. 13 and 14 are very similar, just a little bit longer. So let's see if we can knock these two out. So first of 4 steps, look at your denominators, see what you can factor. So this would be a 2y minus 1. This would be a 3 and a y minus 1. This is y minus 1 backwards, so I'm going to do a negative 1, y minus 1. That means that my lowest common denominator is going to be the 2 times the y minus 1, multiplied by anything in the second denominator that I haven't already written. And now do the same thing for the third denominator. I already have the y minus 1, but I don't have the negative. So I'm going to multiply that by a negative 1 as well. Once I have my common denominator, then I'm going to go with my numerator. So up to the 3, it was over the 2 and the y minus 1. So I'm going to need to multiply by the negative 1 and the 3. Minus the 2. I've already used the 3 and the y minus 1. So we're going to need to multiply by the negative 1 and the 2. Plus the 4. It's got the negative 1 and the y minus 1. So I'm going to need to multiply by the 3 and the 2. I'm running out of room here. All of that. Big old numerator. Now to simplify, I'm going to multiply through each grouping here. That's going to be a negative 9 minus 2 times a negative 1 is 2 times 2 is 4. So it's going to be plus 4. Plus 4 times 3 is 12 times 2 is 24. All of this over, I'm just going to write it as negative 6. Because now that I've got that part figured out, I don't need to have those listed. So that's going to be a negative 9 plus 4 is a negative 5 plus 24 is 19 over a negative 6y minus 1. 19 and 6 do not cancel, but I don't like that negative, so I'm going to pop that up top. I don't like the negative in the denominator, I should say. So I'm going to pop that negative up to the top. And there we go. All right. Let's take a look at number 14. First step, are the denominators factorable? 64 minus x squared. I'm going to do this as a negative, x squared minus 64. Now, do you recognize x squared minus 64? That's a difference. That's a squared. 64 is 8 squared. So this will be a negative x minus 8, x plus 8, x squared plus 7x minus 1. That's a trinomial as well. It should be factorable. What numbers multiply to give us a negative 8 and added give us a 7? It's going to be an x plus 8 and an x minus 1. And this guy's just an x minus 1. So our lowest common denominator should use everything in the first, negative x minus 8, x plus 8. Then we'll look at the second and include anything we haven't already. That's going to be the x minus 1. And then we'll look at the third and include anything we haven't already. Everything's included. Okay. So once we've combined those, just listed them really, I'm not going to multiply it through. I'm just going to leave them listed as factors. Then I need to come up and look at my first numerator, which was x. Do I need to multiply this by anything? Well, I've done the negative and I've done the x minus 8, x plus 8. I don't have the x minus 1. So I'm going to multiply this by x minus 1. The plus that was there and the 4 in the next numerator, which was x plus 8, x minus 1. So these two were used, but I did not use the negative or the x minus 8. So I'm going to need to multiply this by a negative 1 and an x minus 8. Then a minus 5. And that was only over the x minus 1. So I'm going to need to include with this guy the negative 1, the x minus 8, and the x plus 8. That's a longish one. Okay. Now let's simplify what we can. X times x is x squared minus x minus 4x for negative 4 times 8 plus 32 plus 5. I'm just going to do this. And then I know that this x minus 8, x plus 8 is x squared minus 64. All right. Where'd that go? I don't want to stop sharing. Okay. So there's a little bit of a glitch there. I hope we got past it. So I've got an x squared minus x minus 4x plus 32. That's a minus 4 times x, and a minus 4 times 8 is a positive 32. Got a negative 5 times a negative 1. That's a positive 5. And then I just combined these, the x minus 8, x plus 8. I know from here that's x squared minus 64, so that's what I rewrote. That's going to all go over a negative x minus 8, x plus 8, x minus 1. Continuing to combine this, I've got an x squared minus 5x plus 32 plus 5x squared minus 320 all over a negative x minus 8, x plus 8, x minus 1. Still going. Combining further, I can do the x squared and the 5x squared. That's 6x squared minus 5x plus 32 minus 320 is a negative 288 over a negative x plus 8, x minus 8, x minus 1. I changed the order there. I hope you followed that. I just accidentally switched the order. X minus 8, x plus 8, x minus 1. All right. I think this is it. All right. So now this is a trinomial. I need to check and see if it's factorable. So if this is factorable, I need the factors of 6 times a negative 288. That's a negative 1728. Negative 1728 is a huge number to find factor pairs for. So here's a tried and true strategy that I shall give you. When you have very large numbers like a negative 1728, and you only need a difference of negative 5, I look at the square root of 1728. And the square root of 1728, so I'm going to do second square root 1728. And I get about a 41.6. And I like knowing that number because if it was the square root, then the difference would be 0. I need a difference of 5, which means I need numbers close to like 42. So I'm going to take 1728 and I'm going to split it by 42, 43, 44, 45. I'm going to try these and see if any of these three get me a difference of 5. And if they get me a difference that's more than 5, chances are it's prime. It won't work. That's not identifiable. So here's what we're going to do. I'm going to take 1728 and I'm going to divide it by 42. And when I divide it by 42, I get like a 41.1 something. So these are not integers. It's not factorable. I'm going to take 1728 and divide it by 43. And when I do that, I get a 40.218 bunches of stuff. Also, not an integer, so not factorable. I'm going to do 28. This is how you get things wrong, Amy. We're going to divide that by 44. And when I do that, I get a 39.27 bunches of stuff. Again, not an integer, so not factorable. 1748 divided by 45. And I get a 38.8 for repeating. Again, not an integer, not factorable. So I've tried 4 of them, and none of the differences are varying by 5. In addition to that, if I look at this last one, the difference between these two numbers, is more than 5, which means even if I find a pair at this point, they're going to have a difference bigger than 5. There was nothing that had a difference smaller than, what is that, 7-ish, 6 or 7, right? So there wasn't anything at the square root. There wasn't anything as I moved away from the square root. So that tells me that this is not factorable. Okay, it's not factorable. This is prime, and there's nothing I can do. The only thing I might do is take this negative and move it up top before I consider myself done. Just remember that I have to multiply each term by that negative. So this could be a negative 6x squared plus 5x plus 288 all over x plus 8, x minus 8, x minus 1. All right, I'm really hoping the sound went all the way through this because this is the third time I have recorded this video. And if the sound didn't work this time, I don't know if I'm going to do it again. All right. Thank you all so very much. If you have any questions or concerns, please don't hesitate to reach out to me or to stop into the Math Center and get a little bit of help. We'll see you next time.